Assalamualaikum Doctor. My name is Maisara Muhammad Idris. I am from Group 6 and my other teammates are Muhammad Jalaluddin bin Hashim and Muhammad Aiman Izlan bin Maslan. So the title of our project is Autonomous Line Following Robot with Obstacle Detection. We created the robot and we named it Maya 19. We created the robot to achieve our objective, which are the first one, to design a navigation solution for autonomous mobile robot in a controlled environment. A controlled environment here means the type of track that we use, which is a black line track, and also the length of the track. It is being kept constant. Next, the objective is to implement the design element of circuit, mechanical structure, and system operation of an autonomous mobile robot. The problem statement for our group, or this project, is to observe the adaptation of robot, or Maya 19, to the track with an obstacle blocking the path and all the possible conditions available on track for the mobile robots to move along. So this is the diagram for our track. The movement of robot will be from up to downwards. So the robot will turn left once the ultrasonic sensor detects the distance that is within 65 centimeters. So when the distance have become further or more than 65 centimeters, the robot will just move and follow the line like usual. So in this project, we use photoresistor as the IR sensor to detect the white and black background. Next.
Assalamualaikum. My name is Muhammad Aiman Izlan bin Maslan. So today I will present about the Maya 19 mechanical structure. So the first part is the Arduino Uno. The second part is the 9-volt battery. Third and fourth is the motors. The fifth is the H-bridge motor driver IC. Number 6 and number 7 is the IR sensor. And number 8 is the ultrasonic sensor. So basically, the Arduino Uno was placed at the back of the robot. So any connection to the circuit can be easily troubleshoot and connected to the main power supply. By the way, for the breadboard was placed in front of the Arduino Uno because the H-bridge motor driver IC was placed at it. So all the circuit connection can be easily put between the IR sensor and the Arduino Uno with the breadboard. The ultrasonic sensor was placed at the center in front of the robot, so it can detect any obstacle in front of it. Both IR sensor was placed bottom in front of the robot, so it can detect any black and white background on the track. So we move to the flowchart. So the flowchart, we start with the regulation of IR sensor and ultrasonic sensor, trigger pin number 13 and echo pin number 9. At the same time, in the IR sensor, it will read the input from IR left and IR right. But in the ultrasonic sensor, it will calculate the distance of the obstacle. In the IR sensor, it will check either both IR sensor are on white background only. If it yes, it will move forward and repeat again to the first step. However, if it doesn't, it will move and check either only left IR sensor detect black background. If it yes, it will make it turn to the left because right motor is over than left motor and repeat again to the first step. But however, if it doesn't, it will check either right IR sensor only detects black background. If it yes, it will make it turn to the right because right motor is less than the left motor and will repeat again to the first step. However, if it doesn't, it will repeat again to the first step also. In the ultrasonic sensor, the obstacle distance was checked by using the ultrasonic sensor. If the obstacle distance less than or equal to 65 cm, it will make it turn to the left because right motor is over than the left motor. However, if it doesn't, it will move forward because right motor is equal to left motor. Both situations will repeat again to the first step.
Assalamualaikum. My name is Muhammad Jalaluddin bin Hashim. So I will present about the circuit and the result of the program code. So as you can see here, this is the circuit that I designed for this project. The main component that I use is Arduino Uno. Arduino Uno is the main controller in this project. It's like a brain of the robot to control all the movement. It can read input and turn it into an output. The data from the sensor will be given to Arduino Uno and it gives corresponding signal to the motor driver IC. Okay. Next is the motor driver IC. Motor driver IC is used to drive the robot's motor. It receives Arduino signal based on the sensor information. Okay. Next is gear motor. The robot is driven by the gear motor. Gear motor can control the speed of the tire and control the movement of the robot. Next is 9-volt battery. The battery is used as a power supply. The power supply from the motor driver IC to the gear motor. Okay, next is ultrasonic sensor. Ultrasonic sensor is used to detect and measure the distance of the obstacle. And the last main component that I use is photoresistor sensor. I use photoresistor sensor to replace or to mimic for the IR sensor because it's easy to show the result of the simulation by using this Tinkercad. It detects the black and white background. Actually, photoresistor sensor is used to indicate the presence or absence of light or to measure the light intensity. So that's all for the circuit. So now let's start the simulation and see the result. Okay. Alright. Okay. If ultrasonic sensor detect the obstacle within 65 or less than 65 centimeter, it shows turn left, so the robot will turn left. So the left motor will spin slow than the right motor. When the ultrasonic sensor detects the obstacle more than 55 cm or there is no obstacle in front of ultrasonic sensor, so it will move forward. It will move forward and it will follow the line, the black line based on the ultrasonic sensor, based on the photoresistor sensor. Okay. So if both photoresistor sensor detect white background, both sensor will set to the high value, so it will move forward, and both gear motor will spin with the same speed. When the left sensor detect the black background, it will set to the low value, so the robot will turn left, as you can see at the serial monitor. So the right motor will spin faster than the left motor. Okay, lastly, when the right photoresistor sensor detect the black background, it will set to the low value, so the robot will turn right. So the left motor will spin faster than the right motor. Okay, that's all. Thank you.
As for the conclusion, we realized that the robots actually give a huge impact to our daily lives. And it certainly gives a lot of benefits. So one of the benefits is the robot can perform all the tasks which it is set to do. And the factories can make even more robots because the ones making the robots are the robots themselves. So a human operator is not required, and the robot will perform the repetitive task which we are unable to do at times, and the robot will perform the repetitive task, and also they will keep on following the same path. And that's all from us. Thank you.